Okay, here's some homework help. Use these videos just to help guide you through your questions. Your questions won't be identical, but they'll be similar. You can use this video and also use the video that teaches the whole concept. Okay, the first question asks for rational numbers. So rationals are numbers that have repeating decimals. So a rational number would be like -5. 0 would be rational, 59 is rational. This is a decimal, that would be rational. This number would be irrational because it's a square root and it doesn't come out even. This is rational, that one's okay. This is a fraction, that's rational. Fraction, rational. This one, does the numbers keep repeating? So 3, 5, 5, 3, and then a bunch of fives. I don't think they're repeating the same pattern. So I would call this one an irrational. So only those ones I've underlined would be the rational numbers. Next question, which are the irrational? Irrational are numbers that don't start repeating. The square root, those are easy ones to peg. This one, it won't be this one because that one comes out perfectly to 7. So that's an example of a rational number. All these other rational. This one, does it start repeating? There's a pattern there, but it doesn't start repeating the same pattern. And I guess I don't know what happens over here, but just in looking what's happening, um, it's not like 0.3333 where they keep repeating, or 0.13131313. So there's a repeating pattern. It doesn't look like that, so I would probably pick that as an irrational number too. Okay, the associative law means you've got three things, and if you're adding or multiplying, you can pick any two of those numbers to multiply first and then multiply the last one. So here they show the numbers or the variables 12 times x times y, and they're saying let's multiply those two first, which you can do that. And the associative law says that you can also do this. 12 times xy. So you can multiply the xy first and then times it by the 12. Okay, next question. Decide whether a statement's an example of commutative, associative, identity. Okay, this they're just swapping places, right? So if they're swapping places, that's the commutative law. I guess if you think about it, commuting somewhere and going from one place to another place or back, I don't know if that helps you remember, that's the commutative law. All right, next question. Simplifying absolute values numbers. So if I have the absolute value of something, it's basically saying how far from zero are you? And really, when you're doing it, you basically just take the negative out. So the absolute value of minus the square root of 23 will just be the square root of 23. So there's no sign in front of that. Okay, for this next one, same thing. The absolute value of negative 26 over 9 would just be 26 over 9. Now, some of those cases, like if I would have had the minus root, say, root 23, maybe I'll put an x underneath the square root sign. If I had something like that, maybe let's not put a square root on it. Let's just say I have minus 16x, something like that. Since I don't know what x is, I can't really apply the absolute value sign to it. I can apply it to this. So really I could look at this as being, well, what's the square root of negative 16 times by what's the square root of x? Well, the square root of 16 I know is just plain 16, but since I don't know what that x value is, I can't really take the square root of it, and so I'm just going to leave, if you ever have a variable, you can't really determine the square root of that or simplify it, so you would just leave it like that. So if you get a question like that, that's how you can deal with it. Okay, write interval notation and graph the interval. So this says I'm going from minus 8 to positive 8. So minus 8, well, it's not these two, it's one of these ones. So here's minus 8 and here's positive 8. Now, if there's an equal sign, which there isn't, but if there's an equal sign, like if it's less than or equal to, then you use a square bracket to denote that equal to. So this one has a square bracket, so it can't be that one. Has to be this one. Now they want to write it in interval notation. I sort of grew up on this, and I quite like that. But I've learned to really like interval notation too, because all that you do is you say what your smallest number is, -8. Say what your highest number is, +8. And then you put the brackets in depending on if there's an equal sign or not. There's no equal signs, and so I just put the normal brackets on it. There it is in interval notation. Here's another one. So x is less than or equal, oh, there's an equal sign, good. Less than or equal to -5. So here's -5, and I'm going this way. That's good. This one, no, it's going the wrong way. This one's going the right way. Now it's equal to, so it has to have a square bracket to it. That's the one right there. So B is the one, not this one. Now to write that in interval notation, I don't know if you have to do that. Yeah, we do. To do it in interval notation, you do the smallest number. This one, it keeps going this way. So the smallest number would be -infinity. The highest number would be a -5. The infinity always gets a curly bracket like that. This one, because it's equal to, I get a square bracket there. So that's my interval notation for that one. Okay, write the set, all the x's as long as -3 is less than x. So -3 is less than x. That's sort of written funny, isn't it? I guess it's right. -3 is less than x. So if I have on my number line -3 here, it says -3 is less than whatever my x is. So x has to be over here somewhere. So it looks like I could maybe just switch that around and say x is greater than -3. And that makes, to me, this makes more sense than that. And if you flip it around, you just have to flip the inequality too. So they say write it in interval notation. Okay, so my smallest number would be -3, and my biggest number, it says x is bigger than -3, so it can go forever, so it'd be infinity. Infinity always has a curly. Since there's no equal sign, this one also gets a curly. Now to write that in the graph, so it's not an equal one, and it's bigger than -3, so it has to be this one, it has to be that one. Those ones are not right. Our last one? Yeah. Okay, question number 10. This must be our last one. Last question, write interval notation for the graph. Oh, okay. So this one says I have to start at -1 and it's bigger than that. So I can say x is greater than, it's a square bracket, so I can say equal to, not I can, I have to say equal to -1. So x is greater than or equal to -1. So the sets of all numbers x such that x is greater than or equal to -1. Okay, that's set notation, but they want interval notation. Smallest number, -1. Biggest number, it goes on forever, so it'll be infinity. Infinity always gets a curly bracket. This one, since it could be equal to, gets a square bracket. So I have to make it look like that. Looks like this one. No, that has the wrong bracket there. It's this one there. Has to be that one. All right, hopefully that helps you out with your homework for the first section.